Using inverse matrices to solve linear systems. So using them to solve for the x and y in linear systems. Okay. You have to use something called an identity matrix. An identity matrix is when all the ones are on the main diagonal, and then there's zeros everywhere else. So when you multiply and add together, you're going to get 1, 0, 0, 1 in a 2 by 2. When you multiply and add together in a 3 by 3, you're going to get 1, 0, 0, 0, 1, 0, 0, 0, 1. That's how you know you have an identity matrix. Okay. Remember the rules of identity? Say like if I take 5 times 1, I get 5.
Yeah.
Or when I add 5 plus 0, I get 5. Okay. Identity matrix is the same concept. You want all ones and zeros. Now, we have to talk about how to find the identity matrix. To find the identity matrix, you have to use something called the inverse matrix. What does inverse mean?
Opposite.
Yeah, opposites. Okay, opposite. When you find the inverse matrix, it's pretty much a thing you just have to memorize, like a formula. Okay. So if my original matrix is A equals A, B, C, D, okay? My inverse matrix, to find it, this stands for inverse, okay? So when you see anything with that -1 raised to a -1, that stands for the inverse matrix, okay? To find it, you do this. You switch A and D. You make C and B opposite of what they were. So if they're negative, they become positive. If they're positive, they become negative. And then you're solving by putting it under 1. You're solving the, what is that called? Determinant under 1. You're putting the determinant under 1. So you should get a fraction. You might get a whole number because it might end up being 1 on bottom, so 1 over 1, okay? So if I want to find the inverse of this, 3, 8, 2, 5, what do I have to set up first?
You would do make the matrix.
It's all under 1, and then make the matrix what?
3 times 5.
You switch 5 and 3, and what do you do with it?
Make both negative.
Make 8 and 2 both negative. Make them opposite. Now, you have 1 over. Yes, 5 times 3 is? Minus, what's 2 times 8?
16.
Minus positive 16. So you end up getting 1 over -1, which gives you -1 as your identity. Now, from there we have to take it a step further, okay? We're going to come back to what our original, okay. We're going to come back to this matrix right here, okay? We're going to take what we found as our identity, which is -1. And we're going to multiply it in to 5, -8, -2, 3. When you multiply that in, you end up getting -5, +8, +2, -3. Now, this is your identity matrix, the whole answer. Let me show you why. If I take the original matrix of 3, 8, 2, 5, and I multiply it by my identity that I found, what do you think I'm going to end up getting as my answer? Not the same. For an identity matrix for a 2 by 2, what does it look like?
1, 0, 0.
Good. So I should get a 1, a 0, a 0, and a 1. If I take this row by this column, what's 3 times -15? Or 3 times -5, sorry. -15 and 8 times 2 is?
16.
-15 and 16 is 1. If I take this row by this column, what's 3 times 8?
Negative.
Well, positive 24. And then 8 times -3 is -24. So 24 minus 24 is? When I take this row and multiply it by this column, what's 2 times -5? and 5 times 2. So negative 10 and positive 10 is, and if I take this and multiply it here, what's 2 times 8?
16.
5 times negative 3.
Negative 15.
So 16 minus 15 is, so I know that that's the identity because when I multiply it by the original, it comes up to 1001.
Do we have to show all of that or just
You have to get to this part. On some of them, they're going to ask you to prove it,
Okay.
not on all of them. Okay.
Wait, why is he?
Y is equal what? What do you mean y is equal 0? Because when you multiply it out, it gives you 1001. When you multiply it and add it.
Oh, okay, yeah.
Okay. So what that allows us to do is this. If you see an equation that says 2, negative 7, 1, 4, okay, if you see a matrix like this, and then it has a large X like this, okay, you are solving for that X. The X, however, is not one number. When it's large like that, it represents a whole matrix. It wants to know, what did you multiply this first matrix by to get this answer?
Oh,
Oh,
okay, that's not.
Okay, so you would have had to multiply it by what size of matrix? A 2 by 2. Okay, so you know you're going to get a 2 by 2 as your answer. To solve for this, okay, and this will be the last thing that we do. We will not do it with a 3 by 3. To solve for this, you have to first find the inverse of this matrix. So first, find the inverse. Okay, so the inverse of that matrix. So how do I set it up to find the inverse of this matrix? What do I need to do?
A to the negative
What do you do? 1 over
1 over,
the matrix. So
1 over,
8.
I have to do with what with these?
Switch
Switch them. And what do I do with negative 7? And what do I do with 1? Okay, so there we go. Now I have 1 over 4 times 2, which is, and then negative 1 times 7, which is negative 7. Negative 7, okay? And remember that they are being subtracted from each other, so what's 8 plus 7? So you get 1/15. Do you see that?
Yep.
I feel like that's wrong. 7, 1, 2, okay. I feel like it should say 8 minus 7.
No, because you're just
This should be negative 1, that's why. Let me fix it for you to make it easier. So then you get this, 8 minus 7, which gives you 1. We want to try and make it so easy. Try to make it easy. Okay, so 1. So now I have to take that and multiply it by the inverse matrix. So take the inverse and multiply by the matrix you set up. So you're going to say 1 times 4, 7, 1, 2, which gives you 4, 7, 1, 2. But sometimes, remember, it won't, like, on this one over here, it changed it to us, right? Okay, so we get that. Okay, so now we have our inverse matrix, 4, 7, 1, 2. Then, step 3, okay, multiply the inverse matrix by the answers. Does that make sense if I write it that way? So I'm going to take this matrix and multiply it by this answer. So you're
Oh,
going to
so
say,
this is kind of like doing it backwards.
yes, it's working it backwards.
It just doesn't look backwards. That's like the problem I have. It just
Doesn't look like it's backwards?
Yes. Ah.
Okay. So we're going to do that from there, okay? So you know how to do this. We take this row times this column. What's 4 times negative 21?
Negative 84.
Negative 84 plus what's 7 times 12?
84.
Okay. And then the second spot is this row times this column. What's 4 times 3?
12.
Plus what's 7 times negative 2?
-2.
Okay, and then we take this one, this row by this column, negative 1, or 1 times negative 21, and 2 times 12. Okay, and then we take this row by this column, 1 times 3, and 2 times negative 2. Good. So then I get my answer of negative 84 plus 84 gives me 0. 12 plus negative 14 gives me, negative 21 plus 24 gives me, and 3 plus negative 4 gives me, boom. You just solved for what that matrix was that they multiplied by. You have to follow the steps. If you don't follow the steps, you'll mess everything up. So they're taking every piece that we've learned in 3-5 and adding it all into 3-8 for one big problem. Okay? So 3-5, 3-6, 3-7 all led up to 3-8. Which on your quiz over 3-5, 3-6, and 3-7 you did very well. So you know the individual pieces. Now we're trying to put it together. Okay? Now tell me what happens if I have an equation like this. 2x minus 3y equals 19. And let's say I have x plus 4y equals negative 7. And it says use an inverse matrix to solve. Okay? Use inverse to solve. How do we set up our first equation? How do you set up your first matrix?
2,
Uh-huh.
2y1.
2 negative
1.
2, negative 3.
My
2,
And
negative
then
3.
1.
And then 1 and 4. Okay. Now, they're asking us, what are x and y? So what do you multiply this by to get your answers?
Wait, I thought you had to put 1 something.
No.
Oh, excellent.
So I want to know, what did I multiply this by x and y wise to get 19 and negative 7? Okay? Because I have a 2 by 2 times a 2 by 1, so I'm going to get a 2 by 1. Okay? So they want us to use inverse matrices to find this. So first you write the linear system as a matrix equation. Write as matrix equation. Secondly, what do you think we're going to find next? Yes. Find the inverse of matrix A. And matrix A is always this matrix right here. How do I set up the inverse? I have 1 over what?
4,
Mm-hmm.
4 and 3 and 1.
Beautiful. So I get 1 over 4 times 2 is 8. Negative 1 times 3 is, what's negative 1 times 3? How about negative 3? So now I have a blip. 1 over 8 plus 3 is, so I have 1/11. So are you going to have fractions in this answer? Yes. Okay. So you're going to take this, and you have to take 1/11th, and you have to multiply it now by the inverse, remember? What's 1/11th times 4? Okay, good. What is 3 times 111? What is negative 1 times 111? And what is 2 times 111? And then step 3, multiply the matrix of the inverse by the answers. So I'm going to take 4 elevenths, I'm going to take 3 elevenths, negative 1 11th, and 2 elevenths, and I'm multiplying it by 19 and 7, or negative 7. 19 and negative 7. So I am taking a 2 by 2, multiplying it by a 2 by 1, so I should get what size? A 2 by 1. So I'm going to have 2 little blanks like this. Okay. Row by column. What is 19 times 4 divided by 11?
6.9.
6.9?
That's what I have.
Maybe. Let me double check. 19 times 4. You probably will.
Yeah.
Okay. So I get 6.9 plus what is 3 elevenths times negative 7? So 7 times 3, which is 21, divided by 11 gives you negative 1.9. Okay, that's going to make sense. What is negative 1 11th times 19? Just leave it in improper fraction, it's fine.
Oh, it's
Beautiful. Negative 19 over 11. Plus, what is 2 times negative 7 is negative 14 elevenths. We'll change it to a proper fraction in a minute when we do this one. 6.9 plus negative 1.9 gives you what?
5.
5.0. So 5. Fine. And then what is negative 19 elevenths plus negative 14 elevenths? So take 19 plus 14 and you have negative 33 over 11. What's negative 33 divided by 11?
Negative 3.
Negative 3. Yes, they're both negative 3. And boom, you have your answer, your x and your y. All that work to get x and y, yes.